Hey, Mr. Office. I apologize if my air conditioning is really loud and it's hard to hear. But I'm gonna try and talk loudly so that you hopefully can hear. So today we will be talking about PCR, which stands for sorry, which stands for polymerase chain reaction. So I just wrote PCR right there. It's hard for you to see, but yeah. So PCR, what it stands for is or not stands for, but the purpose of PCR is to allow for there to be many copies of DNA to be, or let me rephrase that, many copies to be made of a specific segment of DNA in order to do certain tests or procedures on them as needed. And this is called amplifying DNA. So if you were to put a simple, um, like put the purpose of PCR in simple terms would be amplifying DNA. So um, first you start off with a main DNA strand, which looks like this. So that's your DNA strand. So for PCR, you are taking a specific segment, so let's just say that this filled in area is your segment of DNA that you are interested in looking at. So we're gonna take this and blow it up so that this area right here that I am talking about is the segment of DNA up here. So I would fill it in, but I gotta write in it. So anyway, that's this is the DNA segment of interest that we are gonna be talking about for the rest of the video. So let me quickly add in the um, sequence for this really fast. Okay, so it would look like that, something like that. So that's your sequencing in your DNA. So the first step to PCR is to heat the DNA to around 95 degrees Celsius, and this allows for the DNA strands to denature or separate, um, which allows for the hydrogen bonds in the DNA to break, basically. Um, excuse me. So anyway, that's denaturing is step one to PCR. There's three main steps in PCR. It's denaturing, annealing, and then extending. So denaturing is step one, basically. Um, so then you get to step two, which requires you to cool the DNA to around 60 degrees Celsius. So let me say that this is at 60 degrees. Let's do this in red. So we're going to say now that we are at 60 degrees Celsius, um, we are going to now add primers in, or once it's at 60 degrees Celsius, the primers are now allowed to attach themselves to the ends of the DNA like that, which is this process that I'm talking about here. There's primers attached to the ends of the DNA at 60 degrees Celsius. This is called annealing. Like I said before, that's step two of that's the main step two of PCR. Then the next step of PCR is to once again heat the DNA back up to 72 degrees Celsius, which allows for DNA polymerase to attach itself. So we're gonna that allows the DNA polymerase to attach itself to the ends or to the primers. Just root and DNA polymerase. It's hard to see because it's orange, but which it allows it to attach to the primers that are on the DNA, and this is called extending it. So once you have done all of that, this that's my word straight. That process has been repeated. So you go back to heating it back up to 95 degrees Celsius, cooling it down to 60, back up to 72, all that good stuff. So three main things: denaturing, annealing, and extending. This process is used for fingerprinting, discovering genetic diseases, and just lab procedures, a lot of different lab procedures. And this, in order to get a good amount, you can do this as many times as you want, but it's around 30 to 40 times to get millions and millions and millions of, I shouldn't say millions and millions and millions, but millions of copies of the DNA that you are interested in looking at, which allows for a lot of different, not different, but a lot of the same strands to be looked at, or segments to be looked at for different things, but it's all the same, which is really good for a lot of different things. In this, now in order to figure out what, or how many strands you have of the copy DNA, or how many times, yeah, the copy DNA, you take the, get ready here, so you take the number of original strands, and you raise that, so raise to number of cycles. What I mean by cycles is the number of times that you repeated it. So let's say, in our example, let's just say you started off with 2 strands, like that, and you raise it to the power of, let's just do 40, why not? Let's say you did the cycle 40 times. So you go to your calculator, because I don't think you can do that math in your head, but if you can, great. So we're going to look at your calculator, which I'm using my phone. So you're going to take 2, and you are going to raise it to the power of 30. And you will get your answer. So that is it for PCR. Thanks, Doctor.